Hi, and welcome to another edition with Math with Mr. Douglas. Today, we're looking at the exciting world of integers, specifically how to add them. Are you ready? Let's get to it. Why, hello there. Let's get to it, shall we? We're talking about adding integers today. And as a reminder, when we're talking about integers, we're talking about basically whole numbers that can be positive or negative. So this is what we're kind of looking at today. And we're going to be looking at focusing on adding today. There's going to be other videos about subtracting, but today we're looking at adding. And we're going to tell a story. And in order to tell this story, get comfortable, we're going to tell a story. We need our little math bear, don't we? Of course we need our little math bear. So here's Math Bear. And Math Bear, I mean, he loves math. But he does also like to go and play in the snow. And he likes to go and build snowmen, like all good math bears like to do. And here's our little snowman, and maybe he has a little top hat, and as you guys all know, of course, the snowman needs a carrot nose and that kind of stuff, unless Sven goes and eats that nose. No, we're not talking about Frozen this morning. But anyways, he's going and playing in the snow. And the snow is here on the ground, like that. And then the bear, the math bear, says, you know what's really neat? It's really awesome when I go and I build just a little snow pile. A little snow pile like that. Like, that is really, really cool. Well, what if I went and I built 2 snow piles? So those 2 snow piles are going to be called, well, just 2. How many are there? 2. But then the math bear says, you know what's really neat sometimes is if I go and I actually dig, and I dig some holes, some kind of like snow pile holes, and you get a little hole like this, and then another little one. You go in and dig them, and we're going to call that the opposite 2, just like that. So when you put piles up top like this, that's just 2, and this would be opposite 2. Of course, if I went and added like another pile, then I would say, well, what would that be? That would be 3. And let's just say I went and I dug another little snow pile here, like this, right? Then this would be opposite 3. That kind of makes sense there. Okay, well, the snowman is looking on, and the little math bear is also looking on. He's like, well, so what would happen if we had something that looked like this? So one day, and he's looking at it, and he comes to this, and he says, oh, look, here's some piles. And then he keeps looking down here, and he sees that what he's looking at, it kind of looks like this. Now, quick, hit pause, and what is this? If you had to represent this using the idea that we're using there. Well, if you've unpaused it now, this would be 3, and this would be kind of an opposite 4. Opposite 4. So let's go and actually put this into mathematical practice, shall we? So if you got that, then you have definitely the idea. So let's go and take a look at what this would be then. And let's do some actual math now. So again, so here's some snow. We're going to do a couple of different examples. So here's some examples. And you're like, we're just talking about snow and bears and snowmen and Olaf and Sven and all those sorts of things. Is that, what would this look like right now, mathematically? And I'm going to kind of decide to do that. And so remember, this was 1, and this was opposite 1. So this would be 1 plus an opposite 1. Now, here's the fun part. Here's the fun part. You ready? Let's actually do it. Let's actually go and use the snow. So remember, if you're the little snow bear and you're kind of watching this, you're like, I have a hole there, but I also have a little pile. So what could Mr. Snow Bear go and do? Well, he's going to take this, isn't he? And he's going to go and fill in that hole. If he fills in that hole, then what are we looking at? A completely flat line, aren't we? So we could say that 1 plus opposite 1 is actually equal to 0. We filled in the hole, didn't we? Let's take that little idea and let's just go over here and let's see what this would look like. Let's say I had 1, 2, and 3 piles, but I had 2 holes. And it would kind of make it kind of like this. So what would the snow bear go and do there? Well, he would go and fill in those holes, wouldn't he? He would fill this in, and he would take this pile and he'd fill that one in. So remember, this was 3, and this was opposite 2, isn't it? So you would say 3 plus opposite 2 would be, how much is left over? Well, there's still this one pile, so it equals 1. Let's try one more and see if you completely get what we're kind of doing here with the snow. And hopefully you've kind of got the idea of kind of how to draw these. So here's another one. And let's just say we had 2 little piles, but we had 1, 2, 3, 4, 5. We had 5 holes, just like this. So what would those piles go and do? Those piles would go and fill up how many of those holes? That one and that one. So if you had 2 and you had this is opposite 5, how much would that be? That would equal to opposite 3. There would still be these 3 holes, wouldn't there be? Yeah. Now, obviously, when you've added and subtracted in the past, you've never seen things called opposite 1 and opposite 2 and opposite 3. But I'm using that as an idea here. And the idea is basically saying opposite 1 in integer terms is really negative 1. And opposite 2 is negative 2. And you get the idea. So when we're talking about opposites, we're talking about negative numbers. And if here's your snow, if you're going and digging holes, think of those holes as negative numbers. Well, now let's go and see what kind of happens there. And instead of using opposite, let's go and use these negative numbers. So here's an example. So here's an example, and see if we can go and do this one. So here's our snow. And let's just have this one nice pile there. And we're going to have 1, 2, and 3. 3 holes. Let's go and see if we can write this properly right now. Now the first part should be very simple. Well, how many piles do you see there? This is 1. And this would be plus, how many holes do you see? There's 3 of them. So instead of saying opposite 3, we're going to say negative 3. So 1 plus negative 3. Now, this is where it gets tricky. Sometimes you will see teachers do this. They put brackets around that to make it very obvious that we're going 1 plus a negative 3. You also see some teachers write this as 1 minus 3. This gets tricky, doesn't it? This is all the same thing. I remember we started saying this is like 1 plus an opposite 3 too, isn't it? Like that. It's all kind of the same. Now, some teachers will go back and forth on this. Some teachers will just use brackets, and some teachers won't. Some teachers might introduce rules to you that say whenever you see a plus minus together, you just make it minus. I don't know what your teacher's going to do. But it's good to know the different options. But let's just go and do this question. If I went and actually filled that little hole up, that's my snow sound effect. What would you be left with? Opposite 2, wouldn't you? And what is opposite 2 really? It's negative 2. 1 plus negative 3 is equal to negative 2, or 1 minus 3 is negative 2. Which brings us to another realization, and kind of like also remembering things, is that we also have a number line, don't we? And we know 0 is in the middle. And when we go backwards, negative 1, negative 2, and negative 3. So we need some rules, don't we? Don't we there? When you subtract, you go backwards, right? You go left. So when you had, I'm gonna write this a couple of different ways. So, you know, don't forget like, ooh, what we had there. But when you had 1 minus 3, this just means you started at 1 and you went backwards 3. 1, 2, 3. Oh, look, there we go. Negative 2. When you said 1 plus negative 3, this is where it gets tricky. 1 plus negative 3, well, if the rule is you subtract, you go left. When you add, you go right. But how would you use that rule here? This is adding, but we're adding negatives, aren't we? This is where, personally, I like to get into the habit of saying, when you see plus and minus together, you just make it minus. I think visually it makes it a little bit easier. However, when you use the idea of the snow and the math bear and the holes, this one seems to work out pretty well, doesn't it? 1 plus an opposite 3. You're filling in only one of those negative holes, leaving you with, of course, negative 2. Okay, let's take a look at some just straight up examples here, and I want you to keep those ideas in mind as you're kind of going through this. Now, I'm going to guess this is probably the first time you've ever heard of piles and holes and snow and math bears. So, 5 plus negative 2. And so these are going to be some examples. We'll also do, negative 3 plus 2. And we'll do 1 minus 5. 1 minus 5. Okay, those are the 3 questions. Now, if I asked you, could you write this a different way? I could write this as 5 minus 2. I could write this still as negative 3 plus 2. Nothing really changes there. And this one could also be written as 1 plus a negative 5. I'll just, because I want to make things look really, really pretty like that. And there we go. My question to you, though, of course, because we're talking about snow, is could you draw this with snow? Well, here's our little 5 piles, 3, 4, 5, and we'd have 2 holes. Over here we'd have 3 holes, and we have 2 piles. And over here we'd have 1 pile, and we'd have 5 holes. 3 different ways to represent this. Now, maybe you like certain ways, and that's great for right now. We're trying to learn about that. And you think about it this way, I'm just kind of filling in the holes. And what are you left with? Well, if I did all that, what am I left with here? I'm left with positive 3. So this would be 3. Over here, what are you left with? This one. Minus 1. Over here, you're left with these 4 holes. So we say it's negative 4. Hopefully, you've got a little bit idea of how adding integers works using snow and math bears. All right, hopefully everything is adding up. And we are going to absolutely continue in this next section as we take a look at using absolute value and adding integers. Here we go. While we're going to be looking at adding integers and using absolute value, we're also going to spend a lot of this time looking at adding rational numbers, which is going to be on looking at fractions. But I did want to cover really quickly what it looks like to go and be adding absolute value things. So remember, for absolute value, it's a distance a number is before 0, and you do all the math inside the absolute value bars before that number jumps out and magically, ding, becomes positive. So this is already done for you. So when it jumps out of the bars, it becomes 2. So this just becomes 5 plus 2, which is going to be 7. Okay. But when you have questions like this, though, let's say you had 3 plus 6 plus a negative 4. Okay, like this. You have to do this work inside here. And this is where you can think again to the piles and the holes and the snowman and the little bear. And think about what would that look like? 6 plus a negative 4. Another way, just to remind you guys, is sometimes teachers will write this as 6 minus 4. So you do all this, and you would get positive 2. So 3 plus basically the positive 2. And when the 2 jumps out there, it just remains positive. So this is going to be 3 plus 2, which is going to be 5. Boom. Let's look at some other things. What happens if you had this one? This is always a tricky one. Let's say you had 6 minus the absolute value of, let's say, 3 plus a negative 9. 3 plus a negative 9. Well, you would do the stuff inside the bars, and this would become negative 6, like that. When this jumps out, bing, it becomes positive. But this minus sign is on the outside, so it stays there. So this becomes 6 minus 6, which is going to be 0. And if you write that on your little test, your teacher will be happy, like, yay, good job, you got it. But this, of course, reminds me of, what are the common kid mistakes? So what are the common kid mistakes for this one? Let's take that last example and talk about the KKM, the common kid mistake. So our KKM is as follows. So let's say we have the exact same question. There's 2 common kid mistakes here. The first common kid mistake is to go and say, oh, I'm going to go and I'm just going to make that positive. So this becomes 3 plus 9. So this becomes 6 minus 12. So my answer is going to be negative 6. Haha, I'm right. You're wrong. Remember, you don't turn everything in here positive. You do all the math first, and then you make it positive. That's the very first, KKM number 1. Well, what's KKM number 2? Where else do kids go wrong? So the other place where kids go wrong, I'll show you one more version of this. Kids go wrong by this. So some kids are like, oh, okay, I remember that thing. I have to do all the math first. Okay, that's what Mr. Douglas said. So this will become negative 6, so it looks like this. 6 minus negative 6, but it's going to jump out of here like this and come positive 6. Yay! Okay, and this is what happens. Students are like, oh, they forget about this being on the outside. And they think, well, I don't know, it's kind of close to the bars. Let's just make it positive. And students will go, I can't believe it, but they go and do this all the time. And they go, fine, this would be 6 plus 6. So my answer is 12. Also wrong. Tears will start. People will cry. Those are the KKMs, 1 and 2. Don't fall into that trap. On to adding rational integers. Here we go. So we're going to be taking a look at adding rational numbers. So rational numbers. So we're looking at adding rational numbers. And we're talking, honestly, just about fractions. Now, sometimes students get scared by fractions. Please don't get scared. There are very, very simple things to know when adding. When adding, we must have the same denominators. I like to call those the same bottoms. Okay, so tops and bottoms, numerators and denominators. I like that kind of stuff. So you've seen stuff like 2/3 plus a quarter, right? And in order to have that adding together, you need to have the exact same bottom. And how do we get that? Well, we go and we find what the LCM is. So what's the lowest common multiple of 3 and 4? So the multiples of 3 and 4. So what are the multiples of 3? 3, 6, 9, 12, 16. Oops, not 16, 15. There we go. The multiples of 4 is going to be 4, 8, 12, 16, 20, etc., etc. And what is the common one? Well, it's going to be 12. Ooh, 12. So these become 12s. And then you ask yourself, how did 3 become 12? What did you have to multiply by? Well, by 4. So then you have to multiply the top by 4. So 2 times 4, so that's going to be 8. And how did 4 become 12? You times it by 3. So I'm going to times the top by 3. So now my question says 8/12 plus 3/12. So it looks like this. And when we add fractions, we just add the tops, not the bottom. So 8 plus 3 over 12, our final answer will be 11/12. So that's going to be adding rational numbers. Now there's some more things to that, and some more things we can kind of talk about there. That was very nitty gritty. I'm going to give you guys some hints of how I like to work a little bit, and see if you guys like this. So if we had 5/6 plus, let's say 1/5. 5/6 plus 1/5. A couple of things here. I like to work vertically. I like to work up and down. And the very first thing I think about is what's my LCM of 6 and 5? And honestly, how I usually do it in my head is I just go and multiply. 6 times 5, and that's going to be 30. You're always going to get a multiple. Not necessarily the lowest, but you're going to get a multiple. And then what I do is I always draw these little arrows. These are really helpful. And I say, how did 6 become 30? And how did 5 become 30? What did I have to go and do? Well, for the 6, I had to multiply by 5. And for over here, I had to multiply by 6. And then you kind of say, okay, well then the 5 has to multiply by 5, and I get 25. The 1 has to also multiply by the 6, so I get a 6. And we're adding. So now we get 25 plus 6 all over 30, which is just going to be 31/30. Now, some teachers might say, I want to change that into a mixed number. So it becomes 1 and 1/30. But if you have Mr. Douglas, he wants you to keep it as 31/30, like that. Let's do another one. Whoa. There's a lot of stuff. A lot of stuff being written. Now, where that kind of breaks down a little bit is, let's say you had, I don't know, 5/6 plus 3/8. 5/6 plus 3/8. And you said, I'm just going to use that 6 times 8 thing, right? So 48 as my LCM. And you could absolutely do that. You could do that. And you know that these are multiplying, so the top also has to multiply. And the magical number here is over here is going to be 8. And over here is going to be 6. So 5 times 8 is 40. And 3 times 6 is 18. Okay, so we're going to get 58/48. Now, don't forget, your teacher will always emphasize this. They say, simplify your fraction. Simplify. What does that mean? Well, that means, could you divide the top and the bottom, the numerator and the denominator, by some, I don't know, common number? Well, in this case, hopefully you're like, I can divide both of them by 2. So 58 divided by 2 is just going to give you, what's that going to be, 29. I'll write it over here just for space. And 48 divided by 2 is going to be 24. And then your teacher will be happy. Yay, I'm a happy teacher. There might be that weird teacher that still says, I want it to be 1 and 5/24. That's okay, they're not that weird. But tell them, improper fractions are way, way cooler. Now, maybe you instead said, I want to use the LCM. 5/6 and 3/8. What is the actual lowest common multiple? Well, hopefully you know it's 24. And if you can actually get the LCM, it makes your life a little bit easier because you won't have to reduce and simplify as much. So remember, here we're multiplying 6 times 4, and this is 8 times 3. So 5 times 4 is 20. 3 times 3 is 9. So now we get instantly 29/24. No simplifying needed. And you go straight to the answer. Pretty cool. So different options. Different options. It's always good to have options. Now, what were those negative things though? Let's say we had 3/4 plus negative, let's say 7/9. Just like that. 3/4 plus negative 7/9. Now a couple of things here. Kids will always ask me, is this the same as this or the same as this? Yes, these are all ways to write the same thing. Remember, some teachers, if you saw the first part of the video, will write this as this. Same thing. We still use the exact same principle. We need to have common denominators. So 9 and 4, what are you thinking is the LCM? 9 and 4, hopefully you are thinking 36. So we're going to put this over 36. And 4 times what is 36? 9, right? So that 9. So 3 times 9 is going to be 27. 9 times 4 is 36. So negative 7 times 4 is like this. Now, on the top, we get this. 27 minus 28 all over 36. What's 27 minus 28? Well, remember the snow piles. That would give you like an opposite 1, so again, negative 1 over 36. And there you go. Thanks everybody for tuning in to another edition of Math with Mr. Douglas. Hopefully you got the sum of all the parts. Yes, another bad math joke. Until next time, go and subscribe. And apparently I should ask for a shout out. If you know somebody to shout, have them do that. All right, till next time, have a great day.